Hello, everyone! Today's video mainly explains how to drive the display and touch functions of this development board in the Arduino development environment. The screen of this development board uses SPI interface and MCU. That is, the ESP32-S3 module communicates with each other. Its driver IC is GC9307. Its touch communicates with the MCU through the I2C interface. Its touch IC is CHSC6540. The entire screen and touch parts are physically connected to the MCU through this cable. This FPC looks wider. It's not particularly intuitive to understand how the entire screen is connected. We found a similar SPI screen to demonstrate it to you. This screen is a SPI interface screen. You can see that it has several interface cables connected to the MCU area and the corresponding interface functions. As you can see, if you are familiar with the SPI protocol, you can see that the corresponding parameter annotations above will be more familiar. Here we found a table of the interface protocols of the 4-wire SPI protocol and the 3-wire SPI protocol. You can take a look. The corresponding screen is connected to the MCU in this way. For example, SDA is used to transmit data. SCAL corresponds to the clock signal. We will open Arduino directly for you. Let me explain to you how to drive the screen and touch parts of this development board through code. First of all, in this part of the code, we introduce the GFX_ library for Arduino library. We can find this library in the Arduino Library Manager. Of course, you can also find manual installation on GitHub. The latest version is 1.50. After we install this library, use the header file Arduino_GFX_ library to import this library. Then we can drive our SPI screen. Because the SPI screen is a relatively simple driver overall, there are many third-party open-source libraries that can drive this SPI screen. Here we will only use this commonly used GFX library as an example to explain it to you. The first part of the code is the definition of some parameters. Includes for pins corresponding to the touch screen. Then the screen resolution is 320/170, including screen backlight. The corresponding backlight is the default backlight value of the GFX library. Of course, the following code may not be used. We can just comment it out. The backlight is pin 38. The next part is the most important part to initialize our SPI screen. First of all, it corresponds to a bus of the SPI screen. You can take a look. There are 4 wires in total. That is, the serial numbers of the corresponding for GPIO pins are 11, 10, 12, and 13, respectively, because there are many other open-source libraries. If you use other open-source libraries, need to correspond to these 4 pins to use. Otherwise, it may not be able to drive correctly. Because the driver IC we use is GC9307, There is no direct GC9307 in this library. We use the GC9A01 function to drive the GC9307. These two libraries and two ICs are from the same manufacturer. Many parameters are consistent. It is possible to drive two ICs with the same function. It just needs a function to correct it later. There are two main parameters here that we need to pay attention to. One is the two parameters of its resolution. The following are some parameters about the screen. Please pay attention. These parameters are fixed values, so you don't need to modify. You just need to know what the whole content means. Later, we used LVGL for display demonstrations. Of course, it is also possible to use the GFX library directly. This GFX library brings digital, text, display, and drawing functions. You can directly draw some simple pictures, including text. If you want to display some clock content, you can. But its display effect, including various touch operations, are not as convenient as LVGL. There is no such cool display effect as LVGL. We use LVGL here to demonstrate the entire UI interface. The following part is some initialization parameters corresponding to LVGL. This part of the content is also a fixed content. Our development board has the corresponding content. These are all about some initialization driver parts for the screen and touch. Let's go directly to the setup to show you the entire working process. The first is the initialization part of a serial port. Then comes GFX initialization, which is drawing, a function of lighting and drawing the screen. You can take a look. In this function, we use a function called viewedisplay. Then the main purpose is to correct the difference between the driver IC GC9307 and the GC9A01 we used before. So there needs to be an inverted display. Otherwise, the colors will be displayed incorrectly. Next is the backlight opening. First, the state of the backlight pin changes. Then the backlight becomes a high frequency. The backlight is on. Then we initialize our touch parts. An initialization of LVGL. The following content is an interface between LVGL and GFX. It is also a fixed format and does not need to be changed. Then there is a button initialization of LVGL. Next is a section about multitasking. Let's take a look at how the touch portion of the screen works. You can see that the function used is the wire function in Arduino. You can see that the initialization part is I to C, which is the GPIO pin corresponding to our touch part. Uses I to C communication method. The touch screen should also correspond to our screen resolution of 320/170. This part is an address of the touch ICOX2E. This touch address corresponds to a 7-bit touch address. The following part is the most basic parameters. You don't need to change this part. Just use it directly. Part is an initialization function. Another thing about touch scanning. That is, our touch driver is constantly scanning which coordinates are touched. The entire touch function is relatively simple. If you are interested in this part of the function, you can take a look at it yourself. Let's first take a look at the initialization process of this touch. That is, an I2C initialization, including the initialization of the SDA pin and the SCR pin. Then there is the search about screen touch. It is a logic that keeps searching whether there is a touch. Through this logic, we can keep monitoring whether our screen is touched. Then the LVGL and touch parts have a driver interface in it. You can see that this is the touchpad reading. This part is an interface between LVGL and screen touch. We've uploaded the code now. We exit Arduino and show you the results directly. Because this code is relatively large, if you compile directly, it will take a very long time. The Arduino code I showed you before. The simple code shown in the previous video running on this 1.9-inch screen. The hello word part is relatively short and will pass if compiled directly. The results can be shown to everyone in a short time. But now if we introduce Arduino, LVGL-GFX is introduced in Arduino, and there is also a screen driver part. Putting these codes together, Arduino will search for related libraries. The whole speed will become very slow. Compilation is very slow. Now when we click on the touch screen, a color will be displayed. The size of the entire button will also change. The other display part is to show the function of this button. In this video, we use the GFX library and part of the touch driver code. This makes our 1.9-inch screen have display and touch functions. On this basis, we can do a lot of content related to display and touch control. The corresponding code in this video actually provides the most basic code support for this development board. Okay, this video ends here. Thank you for watching.